Welcome back, chemistry students. Today we are going to learn about oxidation and reduction reactions. The opening slide here has a picture of a classic oxidation reduction reaction, and it's of this vehicle rusting. So the iron oxidizes and forms rust. Another name for an oxidation and reduction reaction, for short we say redox reaction. So that's what we're going to learn about in chapter 20. So what does it mean to have this oxidation reduction reaction? So let's kind of look at what happens. The substance gaining the oxygen is going to be oxidized, while the substance losing the oxygen is going to be reduced. These reactions are called oxidation reduction reactions and are also known as redox reactions. You can't have oxidation without a reduction. They kind of go hand in hand. So if you look at the car here, let's talk about that. So the car is rusting. It's actually oxidizing. The iron metal is gaining oxygen. So you would say that the iron is being oxidized. The oxygen itself is going to be reduced. So that's like what is it saying right here is the substance gaining oxygen is oxidized. So in that photo, the iron is being oxidized, while it says the substance losing the oxygen is reduced. The oxygen in the air is the substance being reduced. All right, let's keep working. So here's another classic example of an oxidation reduction reaction. If you consider the Bunsen burner and methane as the source, you can see from the equation down here that the carbon is going to be gaining the oxygen, because right here the carbon doesn't have any oxygen, so the substance gaining the oxygen is the carbon. So the substance being oxidized here would be the carbon, and then the substance being reduced would be the oxygen. Let's look at a couple more examples. If you consider burning coal, or like in a charcoal grill, it's basically pure carbon, okay? In order for carbon to burn, it's going to combine with the oxygen in the air. So as you can see here, the carbon is gaining the oxygen. So that's the substance being oxidized. So the coal here, or the charcoal, is being oxidized. Another example of this is like the car example, is with iron. You have pure iron right here, and when it rusts, it's gaining oxygen from the air, and it's turning into the iron oxide compound here. So it's being oxidized. Okay, so that's one way. So let me go back. I'll just do a quick summary. That's one way to define a oxidation reduction reaction. So I'm going back. There's a lot of things here. All right. So yeah, this is one way to define it, is the substance gaining the oxygen is going to be oxidized, while the substance losing the oxygen is going to be reduced. Well, that's great if we're looking at a chemical reaction that has oxygen involved, but not all redox reactions have the oxygen involved in it. So I'm going to skip ahead here and kind of show you the best definition to kind of define oxidation and reduction. The best way is this. The substance losing electrons is going to be oxidized. The substance gaining the electrons is going to be reduced. A nice little mnemonic to help you guys remember this whole idea of redox reactions is this. I'll kind of put it down here. Oil rig. Just remember oil rig. That's the one I used when I was in college. They also have Leo the lion goes grr. You can kind of figure that one out as well. But so oil rig is the one I like to remember. So oxidation involves the loss in electrons, where reduction involves the gain in electrons. So that's kind of what it stands for. So reduction equals gaining electrons, and then over here we'll put oxidation equals lose electrons. So it's a nice mnemonic to help remember which is which. So there's going to be a lot of questions asking you is, what is the substance being oxidized? What is the substance being reduced? And if you remember this little mnemonic, you'll remember how to do it. So the way we define oxidation and reduction is right here. So oxidation is now defined to mean the complete or partial loss of electrons or the gain of oxygen. Reduction is defined as to mean the complete or partial gain of electrons or the loss of oxygen. So there's oxidation and reduction. So let's look at an example. So right here we have magnesium sulfur. When they combine, they get magnesium sulfide. At first glance, this might not look like a oxidation reduction reaction because there's no oxygen in this equation. So it's like, well, how do you tell what's being oxidized and what's being reduced? Or is it a oxidation reduction reaction? Well, the way you can tell is if we go to this next slide, if you kind of consider what is happening, you got the magnesium atom, which is neutral, and you got the sulfur atom, which is also neutral. What happens is when they combine, is it's going to involve a transfer of electrons. So here's where oil rig comes into play. So maybe I'll put that at the top here. So oil rig. So if you remember right, oxidation involves the loss in electrons. Reduction involves the gain of electrons. So if you consider what happens when we have the combination of magnesium and sulfide, you can see that. So the magnesium is losing the electrons. As you can see, right, magnesium is giving away the 2, the sulfide ions gaining the 2. So you can clearly see that the magnesium is being oxidized, whereas the sulfur atom is being reduced. And we have the half reactions right here. We'll learn more about the half reactions in the next section. So this would be like the oxidation half reaction. We call this the reduction half reaction. This shows that the magnesium lost the 2 electrons. That's why they're on the right side. This is showing that the sulfur is gaining the 2 electrons. That's why they're on the left side here. So this is kind of showing you guys oxidation reduction. Let's look at a couple more examples here. So there's 2 more vocab words that we have to define. We call it the reducing agent and the oxidizing agent. But this is pretty easy. Once you've identified what's being oxidized and what's being reduced, the reducing agent and the oxidizing agents are so simple to figure out. So I'll say this one's being oxidized, this one's being reduced. We know that, we just looked at that example. So the substance that is being oxidized, or that's doing the oxidizing, is going to be the reducing agent, and the substance that reduces, which would be this guy, is going to be called the oxidation agent. So I'll just abbreviate that RA and OA because that's what I do. So this is being oxidized, it's losing the electrons, so it's the reducing agent. This is going to be the substance that is reduced, so it's going to be the oxidizing agent. So once you figure it out, it's just always the opposite. See how this is oxidizing it? This is the reducing agent. This is the reduced, so this is going to be the oxidizing agent. So let's try to figure this out. So we have silver nitrate reacts with copper to form copper nitrate and silver. From the equation below, determine what is oxidized and what is reduced. Identify the oxidizing agent and the reducing agent. So we have to figure out what's being oxidized and we have to figure out what's being reduced. We have to identify the oxidizing agent, and then we have to figure out the reducing agent. So I'm going to teach you guys a method to figure this out. We're going to learn about oxidation numbers in the next section, but I'm just going to introduce them now because it makes it really easy to figure this out. So a neutral element, like we have here, a single element all by itself, like the copper, has an oxidation number of 0. That's going to be one of the rules we're going to learn about in the next section. So I have a 0 here. There's another one over here, this silver, because it's all by itself there, it's a single element. So that has an oxidation number of 0. Okay, so then what we'll do next is we'll look at this silver over here. Well, it's attached to nitrate, and you guys know that nitrate is NO3 minus, okay? So that must mean that the silver ion has a +1 charge. That's going to be another rule that we're going to learn about for when we assign our oxidation numbers. The oxidation number is going to be the charge associated with it in its compound. So the silver here has a charge of +1. Over here, the copper has a charge of +2 because it's attached to the 2 nitrates. So I'm going to get rid of this. Okay, so we've assigned the oxidation